when a charged particle moves in electric field or magnetic field, it experiences some force. So, a moving charge, whatever be the velocity in electric or magnetic field, it experiences some force. So, now let us consider this the electric field, and this is the plate here, this is the plate and this is the electric field. Direction of electric field is this. Now let us consider a charge is here Q, then it experiences a force, and if this is negative, then this is moves like this. What will be the force? This force is QE. Here let us consider its velocity is 0, then it moves in electric field and a constant force is applied on it. It means there is an acceleration. So charged particle accelerate. Charged particle accelerate, and its velocity goes on increasing. Okay, so acceleration of this charged particle is given by, this is A is equal to force upon mass, and this is equal to QE upon M. So now let this is the first case. The charged particle is stationary here. So now we can write equation of motion for this. V square is 2ax, x for displacement for this charge, a for acceleration, and u is 0 here. So this is V square is equal to 2a for QE by m into x. Okay. Now if force is applied on this and its velocity goes on increasing, then what will be the kinetic energy of this charged particle? So we know that kinetic energy is half mv square. So this is half m, and v square is 2 QE by m into x. So this 2 m cancel. Kinetic energy is equal to QE into x. We know that this distance is x, so V is equal to E into x. This is V for potential. So we write here this small v and this is for potential. So this is E into x is V. So kinetic energy is equal to Q V. V for potential. This is the expression for kinetic energy when charged particle moves in an electric field. Now another case, if charged particle is here and moves with velocity is Vy, then what will happen? Direction of electric field is this and charge moves in this direction, then force on this charged particle is in this direction. This is the direction of electric field. Then we can make the two component. Here is Vx is 0, all this velocity is in y direction. So this charged particle moves like this, and ultimately it goes in the direction of electric field approximately. Okay, so this is the direction of force, and there is an acceleration. So again we can write force is equal to QE and A is equal to QE upon M. Now this is the projectile motion that we have studied in class 11th. It's much similar motion like this. If the height object is with velocity v goes like this, then this is goes like this. So for this we can prove that this equation, this motion is the projectile motion. So now let at this particular point, this is the displacement x, sorry, this is y direction and this is x. So we can write equation of motion for both x and y. So in y we see here there is no acceleration because this is the direction of vy and this is the direction of force. So this vx is influenced by this force. So there is no force on the component vy. Okay, this will remain constant. So now if we write y is equal to ut plus half at square, then acceleration is 0 for y axis, so these terms will 0, and u is we write vy into t. Okay, now for this x is equal to ut plus half at square. So this is x is 0, vx is 0 initially, so this term will 0. So x is equal to 1 by 2, this is qe by m t square. We can write here t is equal to y upon vy. Okay, so this is x is equal to 1 by 2 qe by m, and this is t square is y square upon vy square. This is half qem vy square. Vy is basically the initial velocity, whatever be the initial velocity. So this term is constant, and we write b or any constant capital C is 1 by 2 qe by m upon vy square. Then this is x is equal to cy square, and this is the quadratic equation, and this equation is for parabola. So whenever charge is moving perpendicular to electric field, this is perpendicular to electric field, then its trajectory is the parabola. Okay, so now a moving charge is in magnetic field. So this is for electric field, and now a charge its velocity is v is in magnetic field. Okay, this is x and this is y and this is z, and this is the direction of magnetic field, and a charge is moving in this direction. Then direction of force is given by left hand rule. So this is the magnetic field and this is the velocity, so this will be the direction of force. We can easily understand by this. Let us consider this is the magnetic field, direction is inward inside this board. So this is the direction of magnetic field. Now a charged particle which is moving in this direction, velocity v, then what will be the direction of force? So we know that this finger represents the direction of magnetic field, this finger represents the direction of velocity, and this represents force. So this is the direction of field, this is the direction of velocity, then force will be in upward direction. This is the direction of force. Then what will happen? An object is moving in this direction and force is perpendicular to this. Then if it goes like this, again if this force is perpendicular, then it goes like this, and this performs circular motion. So in similar way, now let us suppose force is in this direction, then it will move like this. Okay, now again This is the direction of magnetic field. Now this is the direction of velocity. So this will be the direction of force. Again force is in this direction, then it goes like this. Again for this velocity we see that direction of force is again right here like this, then direction of force is this. Again direction of force is this. So at a result what we see that a constant force is acting on this charged particle perpendicular to its velocity, so it will perform circular motion. So whenever a charged particle moving in magnetic field perpendicular to magnetic field, then it performs circular motion. Okay, so if it performs circular motion, then a centripetal force is in the center of this magnetic field of this path, basically path. So we know that magnetic field who provide the centripetal force for this circular motion as well as magnetic field, then we can say that magnetic field is equal to centripetal force. Okay, so magnetic field is equal to centripetal force. Okay, both are equal because it performs uniform circular motion with a fixed radius. Okay, so what will be the magnetic force? This is basically force. We know that this is Q V B sin theta, and we see here sin theta is the angle between V and B, and this is the direction of B, this is the direction of B, so this is 90, this will become 1. Centripetal force for a charged particle having mass, velocity V and radius r is given by mv square by r. So V is cancelled, then QB is equal to mv upon r. So we can write formula for r is mv upon qb. So this will be also written as this is v upon b q by m, and q by m is the specific charge. Okay, now if magnetic field is strong, radius will become shorter. If magnetic field is weak, r become larger. So r, radius of this circular path on which the charged particle is moving, is depends on magnetic field. Okay, so what will be the, if this is performed circular motion, then what will be the angular velocity? So we know that v is equal to r omega. So we can write here v is r omega, then this equation is m and v for r omega upon qb. So this r cancel, then omega is equal to qb upon m. Now for time period, this is omega is equal to 2 pi by t, then 2 pi by t is equal to qb by m, then t is equal to 2 pi m upon qb. This is the time period. Okay, so this is the expression for angular frequency and time period. So this is angular frequency and this is for time period. Now we know that frequency is given by 1 by t, then frequency is given by 1 by t, means this is qb upon 2m. This is the expression for frequency. Now Lorentz force, we know that whenever a charged particle moves in electric or magnetic field, or if both fields are present, then it will experience force by electric field and magnetic fields both. So let us consider a charged particle moves with velocity v, where electric field and magnetic field both are present. Then first it experiences electric force, and this is given by F for force, and we write in subscript E, this is QE. Second, it will experience magnetic force, QVB. Okay, so QVB sin theta, basically VB sin theta. So net force, we write here, net force is given by electric force, net force on charged particle, basically electric force plus magnetic force, and this is QE plus QVB sin theta. So F is equal to Q E plus VB sin theta. And this force is known as Lorentz force, or it can be written as in vector form. This is V cross P, and this force is the universal, and this is applicable for both when charge is at rest or whatever be the velocity. For all velocities and for all conditions, this force is applicable. So this we call universal force.